Now, I did want to say, either though neither person is here yet, this would affect, and maybe try to remember your name.
Mike.
Mike, got it.
Yeah.
There you go. Deal. Okay. Two people in the class that had not completed payments as of last week. Now, maybe both of those have. Neither one of them are here right now, so I'm just saying this in case you're listening at home. If you didn't complete payment, there's a good chance you're no longer on the roll. So please, if you are in any way going to finish payment, get it done as soon as possible, so hopefully you can get back on the roll. I don't know if they'll let that, but hopefully they will. Okay. One other sort of minor announcement. I think I made this last time, but in case I forgot, let me say it again. Normally on Fridays, tomorrow, I have office hours from 7:45 to 11:45 on the Birmingham campus. Tomorrow, they've called a meeting for 12:30. So that means my office hours are extended. I'll be there from 7:45 until close to 12:30. I'll have to leave maybe 12:15, 12:20, something like that, in order to go to the meeting. But I actually have longer office hours tomorrow because I'll be in a meeting. But then after the meeting, I'm going home. I won't be back in the office, I don't think, after that. I hope not anyway. Okay. Those are the only announcements I can think of. Let's get the setup from where we left off last time. First, are there any questions on anything we've covered so far? Okay, I gave you the test early. We hadn't quite finished 4.4. We'll finish that today. I don't think there's much on the test that would have been covered by what we're going to do today. But knowing how long the test was, I doubt if we got that far anyway. But you may have. So anyway, we were on example 5. We had done A and B. We hadn't done C. So let's do it. Evaluate each trigonometric function. We'll now do C. Yes. Okay. Well, that's just too bad. No, I'm just all right. Ooh, there it is right there. Thank you. And I was kind of kidding, but maybe kind of not. It is a fairly long test, but I think it's a fairly thorough test. I think it covers everything we've done pretty well. Okay. Now, if you have any problems, questions about the test, like what are you asking for, I'll certainly be able to answer those. The other thing, though, is if you don't know how to answer some of them, find one like it in the book, because every one of those questions, there's something like it in the text. It came out of the test bank that came with the book, so it's related. So find something, one of the homework exercises similar to it. I'll work anything from the book on the board. I won't work the test question on the board. I will answer any questions you have about it, though. Okay.
When is it due?
Technically, it was due, well, no, when we finish 4.4, which will be today, 1 week from today, technically. However, if you need more time, you can usually have it. But please don't hang on to it until the next test time, because I can't give anybody their test back until I get them all in. And, yeah, so please don't be hanging up. Because otherwise, if you wait until I pass out the next test and you turn in that one, then you don't have the benefit of finding out anything you missed, and you may make the same mistake on the second test. So get them in as soon as you can. Try to get them within a week, but if you can't, do it whenever you can. All right, so how do we find out the cosecant of 11/4 pi? How would you approach that problem? You don't need a calculator, by the way. You can do it mentally. How do you do that? You really got two things to compensate or adjust for. What are they? First, what is a cosecant from our identities? Of what? No, it's the cofunction of secant. It's reciprocal of, no, sine. Remember, it goes sine, cosine, tangent, cotangent, secant, cosecant. It's reciprocal. All right. Whitney's here. And Cheston's here. All right. Increase. Okay, good deal. So, again, tell me what cosecant is. Is what? Okay. 1 over the sine of 11 pi over 4. Okay? That's how I would begin it anyway. Now what we have to do is figure out what that is a coterminal angle for. Now there's a couple ways you can do that. One, you can draw you a unit circle or any size circle you want, and start going. There would be 1/4 pi, 2/4 pi, which is half of pi, 3/4 pi, 4/4 pi, 5/4 pi, 6/4 pi, 7/4 pi, 8/4 pi. That's a long way to do it. But you can. You can just keep doing that until you got it. Or you could do what? Divide 4 into 11. What does that do? Oh, high-level math today. 4 into 11 is? Oh, y'all grew up on calculators. Okay. Help me. Stranded here all alone. 4 into 11?
You only go for 11
2 times. Okay, now that's 2 pi. Guess what? 2 pi is one way around the circle. And then what remainder? 3. So you're 3/4 pi left. There's 1/4 pi, 2/4 pi, 3/4. There's where you are, somewhere right there. Okay? Say again? Okay. Now, what is the sine of 3/4 pi? Okay? Think about where you are. You're in the quarter pies, which puts you at, what are the quarter pies usually measured in? The sines and cosines. Square root of 2 over 2. Now you're in the second quadrant, so adjust the signs appropriately. Sine is what on the second quadrant? Positive. So that would just be square root of 2 over 2. Okay, so this would be 1 over the square root of 2 over 2. Now that's one way to express the sine of a quarter pi. Okay, and here is Doc.
Do you have an extra copy of that test?
Of what?
That test.
Okay, you didn't get one before, or you did?
I got one, but I think it got kind of lost in trying to pay for my tuition, and I'm going to put it down.
Okay, I do have another one, but it's not a spare. It probably belongs to somebody else, but since you're here before them, I'll let you have it. I'll let you have it. Okay. But you'll need to, I might need to make a copy for whoever the next person is who comes in. Well, maybe one of the people hadn't paid, so he may not be coming back. I don't know. Okay. Now, did I mark you here? I think I did. Yeah. Okay. Now, there's 2 ways you can go from here. Okay? One, you can reciprocate that. Or the other way, where do we get square root of 2 over 2 anyway? That's the same as 1 over root 2, isn't it? We just rationalize the denominator. That's a lot easier to reciprocate than that other one. So guess what your cosecant is going to be? It's not that hard, is it? Square root of 2. Okay? It's the reciprocal of sine. If sine is 1 over root 2, it's the reciprocal of it. Flip it. And it just becomes root 2. Now, does that make sense? Remember, your sine and cosine are always between plus or minus 1. Your secant and cosecant, because they're reciprocals, are always outside of that. So is root 2 greater than 1? Of course it is. Square root of 1 is 1, so square root of 2 has to be greater than 1. It's about 1.414, something like that. It's approximate. So yeah, that makes sense. Cosecants have to be large like that. Okay. Like pulling teeth. Feel like a dentist. Okay. So, any questions? We had done the first two previously. Remember them? Ready for the next one. Example 6. By the way, there is a checkpoint there. That seemed like that took long enough. Maybe you need to do the checkpoint as well, as soon as you can. Remember, audio-video solutions for the checkpoints are at larsonprecalculus.com. All right, here's how they work them. Don't forget we had done this. I don't remember that we did. Your first one was this one here. Oops. Cosine of 4/3 pi. That would be, and what they're looking for is the reference angle. I forgot that's what we were doing. So you first got to figure out where you are at 4/3 pi. Well, 1/3 pi would be up like this. 2/3 pi is here. 3/3 pi is pi, which is right there. 4/3 pi would be down here. So you're in the third quadrant. You're trying to do a cosine, right? And here we have just okay. So we're trying to do a cosine. What is the SIGN sign of cosine in the third quadrant? Negative, exactly. Okay. All students take calculus. Only tangent and cotangent are positive in the third quadrant. All the rest of them are negative. So you know you're going to wind up with a negative answer. So set that aside. Just remember your answer's got to be negative. Now your reference angle, since it was 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi, that's 1/3 more than pi, right? So your reference angle is pi thirds. What is the cosine of pi thirds? Almost imagine this. Let's just say this is where you are on the circle, whatever, unit circle, whatever. Your adjacent side is here. That's exactly right. All right. This is Sedarius. Locating. Good deal. Okay. We're on top of page 294. We're reviewing what we did last time with the example 5. Okay? Anyone figured it out yet? 1/2. So the cosine of the reference angle is 1/2. What's the sine, SIGN, of that reference angle? Negative. So it's negative 1/2. So you've got your reference angle pi thirds, and you're in the quadrant 3, so it's the negative of the cosine of pi thirds. Cosine of pi thirds is 1/2, so it's negative 1/2. That's sort of the long about way to do it, but that's how they're doing it. And it's perfectly great. It's a good way to do it. All right, now the second one, on the previous page was a tangent of negative 210 degrees. What you got to do is figure out where in the world you are, Waldo. Now, frankly, in my mind, I start counting negative, okay? We did this before, so I won't do it again. But I start going negative 90, negative 180, that would be negative 270. You're not quite there. You're somewhere in the second quadrant, okay? Now, what they did was just add 360 to it, because that gives them a coterminal angle. They got 150, which is in the second quadrant, okay? So, you know you're in the second quadrant. And you have to figure out where, if this is 180, negative 180, and then you go to 210, you've gone 30 degrees past that. So your reference angle is 30. Or, coming this way at 150, you're 30 degrees before you get to the x-axis, negative x-axis. So again, your reference angle is 30. So, your theta prime, which is your reference angle, 30 degrees. Okay, you're doing a tangent. What is the SIGN sign of the tangent in the second quadrant? Negative, because all students, only sine and cosecant are positive in the second quadrant. All the others are negative, so the tangent will be negative. So that will be negative the tangent of 30 degrees. What is the tangent of 30 degrees? Now, if you remember, tangent is opposite over adjacent. So this is, or think of it as sine over cosine. Sine of 30 is sine of 30 is, this is exactly half of that, so that's okay. Is it Kenesha? Oh, Chelsea got it. Sorry. Okay. Good deal. Anyone else come in since the call draw? Does anyone remembered or find out or figured out? Okay. And Taylor, right? Good deal. Anyone else come in since the call draw? Okay. Anyone else figured out what the tangent of 30 degrees is? Again? Square root of 3 over 2, is that what you said? Over 3, okay. Square root of 3 over 3. I don't hear well. Okay? If you remember, it's 1 over root 3. 1 over root 3, which is square root of 3 over 3. Okay? And then the sine is what's the tangent is what? SIGN sign there? You said it? Negative. So it's negative root 3 over 3. So the tangent of negative 210 would be the negative of the tangent of 30. So don't try to remember that. Go through the process to get there. The reason it's negative, you're in the second quadrant. Okay? Tangent, so it's negative root 3 over 3. Very good. Now the one we just did. 11 fourths pi. The way they did it was subtract 2 pi from it. Well, how many fourth pi's is 2 pi? How many quarter pi's is 2 pi? 8. So it's 11 fourths pi minus 8 fourths pi. Okay, this is, just had you. Juwan, right? No, huh? No, I'm sorry. Jeremy, right? There you go. Okay. Now, did I give you a test yesterday? I know you came by. You asked about it. Doc may have taken yours, but let's see. No, he didn't. He took somebody else's. Okay. All right. Okay. Everybody who's here get a test yesterday, last time? Huh? You didn't get one. Okay. Doc didn't get yours either. He tried, but he didn't. Okay. Well, let's see. Whoever the next one that comes in, Doc got yours. Whoever that may be. Okay. So, I showed you 2 ways. Here's a third way. Subtract 2 pi from it, and you get 3/4 pi. So it's 11/4 pi minus 8/4 pi is 3/4 pi. So that's where you are, second quadrant, 3/4 pi. And what we're doing, cosecant. Is that it? I believe it was. And cosecant is reciprocal of sine. Okay? Sine is what sign? S-I-G-N sign in the second quadrant? Positive. So this answer is going to be positive. And it's going to be reciprocal of the sine in the 3/4 pi. 3/4 pi, remember, is over here. What's your reference angle? How far do you need to go to get to full pi? If you're at 3/4 pi, how much do you need to get to pi? 1/4 pi, exactly. So that's your reference angle, okay? So the coterminal angle is 3/4 pi. The reference angle for 3/4 pi is 1/4 pi. And you can do this whatever way you want to do it. This is the way going all the way around. That's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4. Okay, so that took you all the way around here. Or just subtract the 2 pi from it and just do to here. It still gives you 3/4 pi. Your reference angle is what's left. You get to the negative x-axis, and that's pi quarters. So, what's the sine of pi quarters? Just did it. You know, it was a long time ago. It could have been 15 minutes, okay? It's what? It's not negative. You already said it was positive in the second quadrant. What's the value of the sine of pi quarters? Say again? No. That would be pi third. Pi 6. Say again? Square root of 2/2. So that's the sine here. We want the cosecant, which is reciprocal of that. And this is where I say, well, think, how do we get square root of 2/2? That's would be 1/√2. Reciprocate that, and you get √2. Or any way you want to do it there. So your cosecant is the same as the cosecant of pi fourths, because you're in the second quadrant. Cosecant and sine are positive in the second quadrant. That's your reference angle. Cosecant of pi fourths is 1/sine of pi fourths. Sine of pi fourths is 1/√2, so this will be √2. Good deal. Lots of different ways to get there. Just do it right. Any questions? All right. Whoa, last slide. But it wasn't the last thing in the section. Let's go back and do example 6. All right, example 6 says, let theta be an angle in quadrant 2. That's shorthand, okay? We'll let theta be an angle in quadrant 2. Such that the sine of theta is 1/3. The sine of theta is equal to 1/3. Okay? Find A is cosine theta. B is tangent theta. Okay? By using trigonometric identities. All right. Now, tell me how you would begin this problem. Anybody? How would you start it? I think usually a good thing to do first, just about always, draw a picture. Pictures are worth thousands of words, okay? So let's draw a picture of what we think this angle is. Now, I want to draw me a little circle, but I don't want it to be a unit circle. What size circle do you think I want to draw? That's sort of asking a very vague question, isn't it? Okay. This is Sheffield? Jawan, that's right. Taylor, right? Okay. All right. We're on example 6, top of page 295. Been here for a little bit. Anyone figure out what size circle I want this to be? I could probably live with a half circle, but because that's in quadrant 2. But I mean, what radius do I want this circle to be? I hope I gave it away there. Huh? Okay. Okay. Here's what I'm going to look to see. What is sine? It's 1/3. I got that. Okay. What does it mean? What is a sine? In terms of x, y, and r. Y over r. So guess what size circle I want to have? R standing for radius. I want my circle. See, I'm really lazy. You could do a 2, but I want a 3 because those are easier to draw this picture for. Okay? Okay, that's not very even divisions there. I want to draw me a circle of radius 3. That's not a very pretty circle. Okay? Now, and we know it's in quadrant 2, right? Theta's in quadrant 2. And we know 1 must be the y value, so that's right here. And the x value is 3. I mean, the r value is 3, so there is our angle right there. There is theta. Okay? Now, they probably didn't want you to do this, but why not? Okay? That's what it tells you. Y over r, y is 1, r is 3. Okay? That's why I drew a circle. It's easy to pick out that radius. Okay? Now, so we got y equal 1, r equal 3. What else? Oh, they said using trigonometric identities. Why did they say that? So much easier to do it this way. But let's use trigonometric identities. What identity relates sine and cosine? Second? Okay, tangent does, but we don't know a tangent. I want an identity that has only sines and cosines in it. And numbers. Second? Does the name Pythagoras ring a bell? Okay. Sine squared plus cosine squared equal 1. Got it. Okay. So he just told me sine squared theta plus cosine squared theta is equal to 1. And we know what sine theta is, 1/3. So what's sine squared theta? We know sine is 1/3. What is sine squared? I didn't think it was that hard. Say again? Yes, and what's 1/3 squared? 1/9. All right. 1/9 plus cosine squared theta is equal to, how many ninths is 1? 9 ninths. Okay, so it'll be 9 ninths, right? That makes the subtraction easier, doesn't it? Because what's the next thing I'm going to do? Subtract 1/9 from both sides. And that gives me cosine squared theta is equal to 8 ninths. Okay? Now, what do I have to do next? Take a square root of both sides. So cosine theta is equal to, but when you take a square root of both sides, you have to do a plus or minus. Plus or minus the square root of 8 over 3, because square root of 9 is 3. Now you could simplify square root of 8 a little bit. That would be 2√2. So let's see, plus or minus 2√2 over 3. Okay? But that's two answers. I think we only have one. What is it going to be? Plus or minus? Why? Because you're in the second quadrant and cosine is positive in the second quadrant?
Oh, wait.
No, it's not.
I was thinking about sine, but yeah, I got you.
Yeah, but we're dealing with cosine now. All right. So we have to choose the negative. You got it, because you're in the second quadrant. All right, so we'll forget about the plus and just do the minus. So there's the cosine of theta is minus 2√2 over 3.
I got a question. How did you know to use cosine squared plus, sine squared plus cosine squared?
Okay, because as I said, I needed an identity that related sines and cosines, and that's all. And that's the only one that does. Yeah, sine over cosine is tangent. Now you got a third identity, a third function that we don't know anything about. But you can use what you just said to give me the b part. And what is tangent theta? You just told me. What did you just say it was? Someone said it was. Sine theta over cosine theta. And if you're confident in what you just did, we know that sine theta is 1 over 3. And what's cosine theta? Okay, negative. You want to do √8 or 2√2? I don't care. Which one do you want to use? Huh?
We want to be simpler to do.
6 of one, half dozen of the other. I think the book's going to do this one, so I'm going to do it. 2√2. I may be wrong, over 3. And then you could just multiply numerator and denominator by 3, because 3 over 3 is 1. So you haven't changed anything. So this gives you a minus 1 over 2√2. Now, maybe the book likes that answer, or maybe they don't like having a radical in the denominator. So if you didn't, you could write multiply √2 over √2, because that's also 1. And this would become 2 then, and that becomes √2 over 4. Negative √2 over 4. Okay? Now that's just making it look prettier. It's not changing your answer, just changing how it looks. Let's see what the book did. Cosine was negative 2√2 over 3. Yes, we got that right. And the b part was negative √2 over 4. Correct. All right. There is a checkpoint. I would definitely do that. It seemed like it took enough strain and effort to come up with that previous one. So I would do a checkpoint. And if you need help, LarsonPrecalculus.com has audio-video solution. All right, let's do example 7. Okay, last one, I think. So erase all that ink. And it says use a calculator to evaluate each of the following functions. So pull out your handy-dandy calculators and figure out what cotangent of 410 degrees is. what's one thing you better be? You better check on your calculator that you're in. No, that's in degrees. Make sure you're in degree mode for this one. The next one you're going to need radian mode, but this one is in, see the little circle, that means it's degree. Make sure you're in degree mode. Okay? That's step number one. Now, any of you find the cotangent key on your calculator? I think not. Right? So, how are you going to figure this? What is cotangent? Reciprocal of tangent. So that's 1 over tangent of 410 degrees. Make sure you're still in radian mode, degree mode. So you can either do 1 divided by tangent of 410 degrees. Most calculators can handle that. Okay? Or you could do tangent of 410 degrees. When you get that answer, hit the reciprocal key, 1 over x key, x is minus 1 key, whatever that one is, and get your answer. And what do you get? Now, before we do that, I want to have an idea of what we're looking for. Where in the world is 410 degrees? Well, one way to do is subtract 360 from it, right? And what would that be? 50. And that's where? First quadrant. Okay? So we know the answer is going to be positive. When you did it, did you get a positive answer? All right, good. And what answer did you get? Yeah. Is what? That sounds reasonable. About 0.84. Now here's why I said it sounds reasonable. We said that's 50 degrees. Tangent would be greater than 1 because tangent goes 0 to 1 at 45 degrees, so 50 degrees would be greater than 1. But then when you reciprocate that, you better get something less than 1. That seems pretty reasonable. Let's see what they got. 0.8390996. Yeah, 0.84 is good enough for me. Okay? The B, this is A. The B here is sine of -7. Says use a calculator, so what did you better be in? Radian mode, because you don't see a degree symbol. If you saw a degree symbol, -7 degrees makes sense. You don't have that. It's -7. Where in the world is -7? I want to have an idea of what kind of answer I'm looking for. Where do you have to go to get -7? Negative, you start going this way. And in radians, what is one way around, all the way around? Well, let's do it halfway. Let's go to here. How far is that? In radians. Pi. And pi is how much? 3.14. So you're negative 3.14 here. You go to 2 pi, you're going to be negative 6.28. So you're past that. And guess where you are then? Just a little past that. Fourth quadrant. Okay? We're doing the sign. What's the SIGN sign of the sign in the fourth quadrant? Negative. Okay? So I expect it to be a negative answer. And I really don't expect it to be a very large negative answer. Okay? Because the reference angle is a pretty small angle there. So do it and see what you get. .656. Actually, it's bigger than I thought it would be. And that's exactly what they got, negative 0.65. They got 657. Is yours round to that? They got negative 0.656986. I don't care. Negative 657 is fine with me. All right. The C one then is secant of pi ninths. Okay? First thing I'm going to ask myself is, where in the world are we, Waldo? It's where?
It's 45 degrees.
It's less than 45 because pi force is 45 degrees. So it's considerably less than that. Huh? You're in the first quadrant, for sure. I mean, pi is 3.14 and 9 is, 9, so that's less than 1/3 of a radian. You're in the first quadrant. Okay? Now, any of your calculators have a secant key on it? I think not. So what relationship are we going to need here? What is secant? 1 over cosine of pi ninth. That's how I would do it if I were using a calculator. Okay? Now, when you go to do the cosine of pi ninths, I bet you most of your calculators have a pi key. So do 1 divided by cosine of, it opens a parenthesis for you already, most of them do anyway, find the pi key, divide by 9, close the parentheses, what you get. Okay? Now first, let me think. A very small angle, pi ninths is a very small angle. The cosine is going to be a pretty large number, like 0.9 or so, because cosine of 0 is 1. So this is going to be the reciprocal of a fairly large number, which is going to be large number less than 1. So the reciprocal of that is going to be just slightly more than 1. And what do you get? Anyone do it? 1.06 or so. Yeah, pretty good. Any questions on that? They also have a checkpoint here. Please do those. Okay, that finishes 4.4. Let's do the vocabulary. In the first X exercises, let theta be an angle in standard position with XY being the coordinate points for it. A point on the terminal side of theta. And let R be square root of x squared plus y squared. Not equal to 0. All that is standard. So you tell me what sine theta is in terms of x, y, and r. What is sine theta in terms of x, y, and r? Y over r. Number 2, r over y would be what? Cosecant of theta. Perfect. Tangent theta would be y over x. Excellent. Number 4, secant theta would be r over x, you said? Yes, perfect. And x over r would be cosine theta, and x over y would be cotangent theta. Excellent. Number 7, because r is the square root of x squared plus y squared, and that cannot be blank, zero. It also cannot be negative. Either one of those work, but they're looking for 0. The sine and cosine functions are blank for every real number theta. There's several words you can put in there. I would use the word defined, or that is as good as any, for any real number theta, any real value theta. Okay, number 8. The acute positive angle formed by the terminal side of an angle theta with the horizontal axis is called the blank angle of theta and is denoted by theta prime. Reference angle, you got it. Homework exercises here, I've assigned most of these before. Do either 1 or 11, 9 or 11, or both. They have 2 parts each. Do any of the odds 13 through 17, either 19 or 21, any of the odds 23 to 31, either 33 or 35, any of the odds 37 to 43, any of the odds 45 to 51, any of the odds 53 to 67. That's probably about where I left off last time. So then the new ones would be something like any of the odds 69 to 73, any of the odds 75 to 89, any of the odds 91 to 95, and any of the odds 97 through 101. Okay? There is an exploration with a true-false 103. I would take a look at that anyway, and maybe look at 105 or 107. There's not anything you have to do on those, but think through them and see if you understand what they're talking about. Any questions? Second? Okay, the homework ones. Either 9 or 11. Okay? Any of the odds 13 to 17. Either 19 or 21, or both. Any of the odds 23 to 31. Either 33 or 35, or both. Any of the odds 37 to 43. Any of the odds 45 to 51. Any of the odds 53 to 67. Any of the odds 69 to 73. Any of the odds 75 to 89. Any of the odds 91 to 95. And any of the odds 97 to 101. Okay? Any questions? 4.4. Okay. Everybody got a copy of the test, first test. It covers, you didn't? Okay. Doc, you stole his. Okay. I'll have to make you a copy right after class. Okay. Let me get that out. So I will do so. Okay. And technically, they're due 1 week from today. Of course, if you need more time, you can have it. But please don't wait till the next test is due, okay? Because then you don't have a chance to learn from your mistakes on the first one. And guess what? I can't return anyone's test until I get them all in. So everybody get them in as soon as you can. Shoot for next Thursday, but if you can't, get them in as soon after that as possible. All right. Now, all right. Let's move on to 4.5. If I haven't told you this already, or if you weren't in Math 112 and used this text, you may not realize, but be aware, this book loves graphing, okay? And this section in trigonometry is graphs of sines and cosine functions, okay? The next section is the graphs of the other functions, okay? So we have 2 sections here doing basically nothing but graphing the functions. So what are our objectives in this one? Sketch the graphs of basic sine and cosine functions. Use amplitude and period to help sketch the graphs of sine and cosine functions. We'll sketch translations of the graphs of sines and cosine functions, and we'll use sines and cosine functions to model some real-life data and solve some real-life problems. So let's look at the basic sine and cosine curves. This section will study techniques for sketching graphs of sine and cosine functions. The graph of a sine function is often called a sine curve. So we use those interchangeably. Sine graph or graph of a sine function or a sine curve. And basically this is what it looks like. Now they only darken what they call one period of this curve. Sine starts at 0 because the opposite, the angle 0 is 0, okay? So let me start at 0. It moves up to 1 at pi halves, okay? Goes back down to 0 at pi, then goes to -1 at 3 halves pi, and then starts over where you started before at 2 pi, and then repeats itself and repeats itself and repeats itself and repeats itself from now to the end of time. If you go backward, it repeats itself and repeats itself and repeats itself. So this is called a periodic function, because every now and then it just starts repeating itself. Okay? It's called a periodic function. Now, what's the domain of a sine function then? All real numbers, absolutely. You can put in any number in the world. There's no place that that sine function does not have a value. Now the question, what's the range of it?
All real numbers from what?
-1 to 1, right there. You're absolutely right. It can be -1, it can be +1, it can be anything in between, but it is never outside -1 to 1. It can't be less than -1. It can't be greater than +1. It's always within -1 to 1. So if you ever have a problem that says sine of theta is equal to -2.3, no solution. Sine of theta is equal to 1.7, no solution. It can never be outside of -1 to 1. Okay? Now this shows some of the values we're used to. I pointed out 0 at pi halves, pi, 3 halves pi, 2 pi, but they threw a few more in here. That looks to me to be pi 6, pi fourths, pi thirds, pi halves. That's pretty much what they are. For some reason they did 3/4 pi over here too. Those are just some, frankly, the key ones are these 5 right there in one period. The first, the last, and the 3 in between. Actually, here's how I usually do it. I do first and last in a period, halfway between, and then halfway between those. You got those, you got pretty much the shape of it. Okay? Periodic function. It repeats itself indefinitely to the left and to the right. Now, that looks similar. What's different about it? The sine function started at 0. The cosine function starts at +1. We knew that, didn't we? Okay? But other than that, they look almost identical. Cosine of 0 is +1. Pi halves is 0. Pi is -1. 3 halves pi is 0. 2 pi, back where we started. Periodic, it goes up forever and forever and ever in both directions. What's its domain? All real numbers, its range between -1 and 1. Got it. Okay. Period. 2 pi. That's where it starts repeating again and again and again every 2 pi. Okay. Good deal. That's what the basic graphs of your sine and your cosine functions look like. That's what sine and cosine curves look like. Okay. And they did do a few of the other points. This is cosine of pi 6, which is square root of 3 over 2. Pi fourths is square root of 2 over 2. Pi halves is 1 over 2. And pi halves is 0 again. And for some reason they did another 3/4 pi there. I don't know why they do one of those but not the rest. Whatever. Okay. We know that the domain of the sine and cosine function, as we said, all real numbers, or over the range of these is -1 to 1. That's written in interval notation. Why bracket? Because it counts -1 and 1. They're included. And each function has a period of 2 pi. It says, do you see how this information is consistent with the graphs? Yeah, we've been talking about that all along. Okay? So, any questions on that? Note that in both of those figures we just saw, the sine curve is symmetric. Okay, let's go back and look at that. Sine curve is symmetric about the origin, not the y-axis. If it's symmetric about the y-axis, this would be over here. It's not. It's symmetric about the origin. Whereas the cosine curve is symmetric about the y-axis. Very good. That means sine is an (2468) or 1257. Sine is an odd function and cosine is an even function. You got it. The odd function is symmetric about the origin, even function is symmetric about the y-axis. Okay? The other way to think of that, an odd function, f of x, is the opposite of f of negative x. And sure enough it is. Whereas even function, f of x, is equal to f of negative x. All right. Those properties of symmetry follow from the fact that the sine function is odd, cosine is even. Okay. They got around to it. Now, to sketch the graphs of the basic sine and cosine functions by hand, okay, it helps to note 5 key points in one period of each graph. So guess what you got to do? Figure out what a period is for that graph. Okay? And what are those key points? They're the intercepts. Now there's only one y-intercept. That's usually where you begin. That's there or there. Okay? But the other intercepts are the x-intercepts, where it crosses the x-axis. Where it crosses the x-axis. And then the max and the min points. So those are the ones we're interested in. Okay? And basically, find the period. The two ends of the period are either going to be 0 or they're going to be a max or min. One or the other. Okay? Find those. Halfway in between, you got another one. And halfway in between each of those, you got another. So those are going to be your key points. The end point of the period, beginning of the period, the end of one period, halfway in between that period, and then halfway in between that. Okay? Same thing here. Beginning point, end point, halfway in between, and halfway in between each of those. Okay? That gives you, whichever function, those are the key points that we're going to get. And once you have those, you can sketch them in pretty easily. Okay. The key here for the sine function, it begins and ends one period at 0. So in other words, the sine starts at the origin, 0, 0. One period later, it's exactly 0 again, 2 pi 0. Halfway in between that, you're at 0 again, okay? At pi, you're at 0. And halfway in between the first two nodes, you're at the max. Between the next two nodes, you're at the min. Okay? Plus 1, minus 1. Okay? Cosine starts at 1, 0, 1. So it's got to end at 2 pi 1. It'll wind up where it started. Because it's periodic. Halfway in between that, and those are maximum by the way. So halfway in between, you got a minimum. That's a minus 1. Pi minus 1. And halfway in between these, you got a 0. Okay? So, pretty easy to determine those 5 points. Okay? Now, you'll need this later, but I'll go on and tell you now. Okay? How you figure out where those points are, you figure out the period, right? Whatever the period is, divide by 4. Because you see, this is 1/4, a quarter period, half period, 3/4 period, quarter period, half period, 3/4. So find what your period is, divide by 4. That gives you and then you just increase those 3 times, 4 times, and you got the whole, all the points you need. All right, any questions on that? Okay. Here is example 1. Sketch the graph of y is equal to 2 sine x. Okay. I really hate they did this to you. They have not defined something for you, and they're expecting you to use it. I'll go on and define it for you. Okay. Sketch the graph of y is equal to 2 sine x on the interval from minus pi to 4 pi. Okay? Boy, I got an itchy nose. Now, in the very next subsection, on the very next page, they're going to tell you what this is. Okay? This right here is called the amplitude, A. Usually we give the symbol little a, but it stands for amplitude. Okay? Or we use that. Okay? Now what does that do to the sine function? Normally the sine, yes, it raises or lowers it. It stretches it, a vertical stretch. So this function is going to go from plus 2 to minus 2. Sine only goes from plus 1 to minus 1, but you're multiplying by 2, so that allows you to go from plus 2 to minus 2. So when I go to draw my graph, okay, then I need to make sure that I go from plus 2 to minus 2. Now, I'm going to warn you on this too. Don't think my vertical scales and horizontal scales are going to be the same. I set them up for whatever I want them to be. And therefore, I knew I wanted that to be 2. If I needed 3, I would have made them smaller and made 3. If I needed 5, I would have done that. If I needed it to be 1/2, I would have done, much bigger. Okay, so now it says go from negative pi to 4 pi. Okay? Now, remember, in a period, you have 5 key points. A period is 2 pi. So negative pi is going to be 2 key points, or 3 if you count that one. So this is going to be negative pi. I hope I allowed enough space. Sometimes I don't. So this is going to be negative pi halves. This is going to be pi halves, pi, 2 pi, 3 pi. Yeah, I did enough. 4 pi. Yeah. Okay? That's what I want to graph. Okay? Now, where does sine begin? What's sine of 0? 0. And at the first key point there, which is your half pi, where does it normally go? Sine goes to sine of pi halves is 1. Except we're multiplying that, so that's going to go to 2. At pi, it comes back to 0. At 3 halves pi, it goes down to your minimum. In this case, it's minus 2. At 2 pi, it goes right back where it began and starts to cycle over again, right? So it'll go up to 2, down to 0, down to negative 2, up to 0. That's as far as we need to go. Going in the opposite direction, it goes down to the minimum, which is minus 2, then back up to 0. That's as far as we need to go. So here's a sketch of that curve. Whoa, bad, bad, bad. Okay. Now, I kind of messed that up here, which means I need to fill that back in here. Okay. Now, a couple of things about drawing your curves. Make sure they're curves. That's not very curvy, is it? Make sure at the max and min that you do have a curve. That's not very curvy. That was a little better. That's not too bad. Okay? Be sure you cross at the intercepts. Okay? Determine those ahead of time. Plot them. And do your max and ends ahead of time. Plot them. And then try to make the curves match. Okay? That's not very pretty. Okay? It's got a little too jagged or pointed. Not even connecting well here. But that's the general idea. Okay? So there's your graph of that. Okay? They threw that 2 in there without telling you what it was. That's called an amplitude. That expands vertical stretch. Okay? So let's clear this out of the way. No, that's not what I want to do. This one. And let's look at this. Note that y is equal to 2 sine x. Yes, okay? Is equal to 2 times sine x. Oh, that's clever. And that indicates that the y values for the key points will have twice the magnitude of those on the regular sine function. Now, twice times 0 is still 0. So all your nodes are still going to be at 0. It's just your max and min, they're going to be stretched. Well, everything in between, but those are the only ones we're plotting. So, and they like to set this up this way. If you like this, go for it. First intercept for sine is 0, 0. That makes the last one 2 pi 0, because it's 1 period later. Makes in between pi 0, okay? It makes in between this, because sine starts going up, goes up to the max, in this case it's 2, and in between those it goes down to the min, which is minus 2. So pi halves 2, and 3 halves pi, negative 2. Make sense? I just do this on the graph. I don't usually write it out. But if you find writing it out is easy, makes you see it better, go for it. All right. By connecting those key points with a smooth curve and extending the curve in both directions from negative pi to 4 pi, then this is what you get. Okay? Now, your original was your sine curve. That's what they did. I did not draw that for you. We just talked our way through it. But then 2 times that will double every point here. Every point. But the key points are this one, this one, this one. Doubling the zeros keeps it at 0. Or they just put a dot here, I'm not sure. And doubling your minimum from -1 to plus minus 2, for plus 1 to plus 2, minus 1 to minus 2, plus 1 plus 2, minus 1 minus. Okay? 1 period is 0 to 2 pi. 4 pi is just another period. The negative pi is half a period. Make sense? Okay. Plot those key points first, connect the dots. This feels like what you used to do as a kid, connecting the dots. Okay, any questions on that? Now, finally, they get around to there is a checkpoint. Please do the checkpoints. Okay? Goodness gracious. There is a little, and this is probably somewhat important here, a little technology side note here. When using a graphing utility to graph trigonometric functions, pay special attention to the viewing window you use. For instance, try graphing y is equal to sine 10x over 10 in the standard viewing window in radian mode and do a zoom with it. So I don't know. If you got a graphing calculator, pay attention to that. I'm not going to go into it because we don't have them in front of us. If you got one, walk your way through it. If you have questions, come see me. Okay, so now let's look at amplitude and period. We already defined period, and I've already introduced amplitude to you, but these are the first 2 key elements we do graphing any functions. Now, they're going to start with a much more generic equation, okay? For the life of me, I do not see why they they express it the way they do, but they do. Maybe there is a reason. If I were writing this, I'd say y is equal to a sine. I would pull the b on the outside, bx, and put a minus c in there, and then put a plus d over here. So you have a, b, c, d. They did the d in front, which is perfectly fine. We're not going to talk about d yet. We're going to talk mostly about a and b. But, I'm sorry, just about a. Well, b something. Let me tell you what the others are. We've already mentioned A is amplitude, which is your vertical stretch. That's a non-rigid transformation. The B is a horizontal stretch, which affects the period, because that's what's on the horizontal axis. The C here has to do with a horizontal shift. It's not a horizontal, it has to do with it, but it's not exactly. That's why I would have pulled the B on the outside and left a x minus c in there. That would have been exactly your horizontal shift. And D is your vertical shift. We're not doing the others yet, but this introduces all the possibilities. And then the same thing with cosine. B is a vertical shift. A is amplitude, which has to do with vertical stretch. B has to do with horizontal stretch or shrink. And it really should be on, I think, on the outside. The book doesn't do it that way. C has to do with, the way they write it, has to do with the horizontal shift. If you had pulled the B on the outside and left just C on the inside, that would have been the horizontal shift. But they didn't do it that way. The constant factor A in this thing, y is equal to a sine theta, acts like a scaling factor, a vertical stretch or a vertical shrink. If A is greater than 1, it's a stretch. Between 0 and 1, it's a shrink. The basic sine curve. Now they say absolute value of A is greater than 1, it's a stretch. And absolute value of A less than 1 is a shrink. And that's correct. Okay? But usually, we'll get to it later, what it means for the A and B, positive or negative, but we won't get into that right now. Okay. In fact, we're not going to get into much else right now, are we? Let's see, where are we here? For some reason, this slide is the middle of a paragraph, and it's that paragraph right there on page 301. So, all right, we will start there. Let me give you just a few more, not too many more, homework exercises. This is sort of a long section. Okay? Oh no, I don't think you can do any of these yet. Okay. No new exercises in 4.5. Just do the ones in 4.4 and your test. That'll be enough to be fiddling with now. Any questions before we move on? All right, I think we are just about out of time, so have a good weekend. And, of course, working on trig problems will make it a good weekend, won't it? Yes, it will. Okay. So.